Okay, so this problem is chapter 5, number, too big. Chapter 5, number 37. Too small. Yeah, better. Chapter 5, number 37. So this question states that there is a spring scale that is reading the weight of a 54 kilogram woman. So 54 kilogram is the mass of the woman in an elevator. So here's the elevator, and here's the scale that she's standing on. And the question says, part A, what is the weight of her if she is moving at a constant speed upward, constant velocity going up at 5 meters per second? Now the answer to this is, if we were to draw the free body diagram, we have a normal force going up, and we have gravity acting down. But what we would write in this case is we'd say sum of the forces in the y direction equal the net force in the y direction. But you see, since we have a constant velocity, acceleration, which is what F net equals, acceleration would equal 0. Therefore, what we would have is the summation of the forces in the y direction equaling 0, because that is 0. So that means that in this case, Fn equals mg, since we have Fn minus mg equaling 0. That means this and this are equal. And her apparent weight, and this is actually important, this term apparent weight, because a lot of times when you hear this term, it's actually referring to the normal force. So apparent weight is the normal force, and that's the force with which a scale will push on her. So in this case, the answer would be her apparent weight is simply mg, or 54 times 9.8. Now part B asks the same exact question, except this time she's moving with a constant downwards velocity. If she's still moving with a constant velocity but it's down, it doesn't change the problem. The answer is still the same. The answer is the same. Part C says with an upward acceleration of 0.33 g. Now this one does change. So now what we have is summation of the forces in the y equals ma, but particularly now we can just go equals F net, which is ma, and in this case a is going to equal 0.33 g. So what we have, again, we have Fn minus mg is equal to m times 0.33 g, because the acceleration is given. We're still looking for Fn. That is the apparent weight. And so we can say, put the mg, take this term to the other side, it becomes a positive. And so we can factor out this m now here and here, and we get g plus 0.33 g, and we can therefore add those two, and we'll get m times 1.33 g, and that's our answer, or 1.33 mg. So in fact, if the elevator is moving upwards with an acceleration of 0.33 g, this person is going to end up feeling 33% heavier. And the next problem, D, says with a downwards acceleration. So it's the same exact situation as C, except in this case, this term here ends up being a negative because we've decided that up is positive because that's the direction when we chose Fn. Here, we chose up as being positive. So we said Fn minus mg, mg being negative. So in fact, it would just be Fn minus mg is equal to m times negative 0.33 g if it's accelerating downwards. So we've got to solve for Fn. This is really easy. It's just going to be mg minus mg times 0.33 g. And so we're going to get, if we factor out the m, we're going to have that. And so 1 minus 0.33 is going to equal simply 0.66 mg. So in this case, we're losing a third of our weight. Okay? And finally, question E asks, what about if the person was in free fall? Well, the answer to that is simple. The person's going to be weightless. Now, if you think about that, why is that? Now, if you're in free fall, you are weightless. That is true, and I could answer the question just from personal knowledge. But what would the math look like? If I went summation of the forces in the y direction is equal to F net, and that's equal to MA, what's my A if I'm in free fall? Isn't it down at 9.8? So now, if I follow through with my equation, Fn minus mg, remember the free body diagram looks like this, where you have Fn going up and mg going down. So now, well, if I now follow through for Fn, if I take this guy to the other side, it's simply going to be mg plus ma. But remember, A is negative 9.8, so it's going to give me 0. So there you go. We've just proven mathematically that in free fall, your apparent weight, that's what Fn is, your normal force. Your apparent weight is going to be weightless. Okay? Well, thanks for watching, and see you next time.